Good morning, one and all. This is Dr. Vikas Jadhav, working as Assistant Professor, Department of Statistics, Sanjivani Mahavidyalaya, Kapoli. Dear students, in previous 2-3 lectures, we have seen the unit number 1, that is sequencing problem. In this unit, we have already discussed the introductory part of sequencing problem, objective of sequencing problem, purpose of sequencing and scheduling, and basic definitions, terminology of sequencing, and last one, some general assumptions of sequencing problem. These all points are highlighted on previous 2-3 lectures. So now, dear students, today we are going to discuss the most important topic, that is the processing of n job through 2 machines. So the simplest possible sequencing problem is that of n job through 2 machines sequencing problem, in which we want to determine the total elapsed time, capital T. Here the problem can be described as only 2 machines. Here only 2 machines, machine A and B, say A and B are involved in this processing. Each job is processed in the order AB. The exact or expected processing time A1, A2, so on of AN, B1, B2, so on of BN are given. So this is the 2 machine A1, A and B, and these are the jobs 1, 2, so on of N, and these A1, A2, B1, B2, so on of AN, BN. These are the processing time of n job through 2 machines. This mathematical formulation or the solution of the above problem is known as Johnson's procedure or Johnson's rule. This is called as Johnson's procedure or Johnson's rule. So now we come the algorithms of the n job 2 machines. The algorithm can be stated in the stepwise manner. They are as follows. The step first, select the smallest processing time occurring in the list A1, A2, so on of AN, B1, B2, so on of BN. We select the smallest processing time, and if there is a tie, then either the smallest processing time can be selected. Same step second, if the list processing time is AR, select the rth job first. It means that if AR, that is the processing time of rth job, the processing time of rth job on machine A is the smallest, then do the rth job first in the available of sequence. If it is BS, do the sth job last as the given order is AB. It means again that if BS, that is the processing time of sth job on machine B is the smallest, then do the sth job last in available position of the sequence. Now third step, there are now n-1 jobs left to be the ordered. It means remove the schedule n-1. Repeat the step 1 and 2 for the remaining set of processing time obtained by deleting the processing time for the both machine corresponding to the job already assigned. It means in step 3, remove the assigned job from the processing timetable. In step 4, continue in the same manner till the entire job have been recorded. The resulting ordering will minimize the total elapsed time, capital T, and is called the optimum sequence. Optimum sequence means either it is minimize or maximize. Our sequencing problem is to minimize the total elapsed time. Here the minimize, optimum means the minimum sequence. Now next to the final step, the step 5. After finding the optimum sequence, as stated above, find the total elapsed time and ideal time on machine A and B under, already in previous lecture what is meant by elapsed time, ideal time. The total, how to calculate total elapsed time? The time between starting the first job in the optimum sequence on machine A and completing the last job on machine B. So this is the total elapsed time. Total elapsed time, the time between starting the first job on machine A and completing the last job on machine B. So how to calculate the ideal time on machine A and machine B? The ideal time on machine A is equals to time when the last job in the optimum sequence is completed on machine B, then minus time when the last job in the optimum sequence is completed on machine A. So these are the basic, these are the important steps of n job through 2 machines. Now in the next lecture we will see the numerical example based on the above algorithm. Thank you.